Alright, g'day Year 9s. So I've just started the live stream, and if I can just get you to go on to Sector in the forum just to say hi. I'm disabling the live chat in YouTube for the actual main part of the lesson. I will enable it again later in the lesson for when we have questions, but when I'm delivering the content, just so that we can not get distracted by comments that people make in certain things, just disabling the live chat. So I will enable that in a minute, but if you could just jump onto Sector Forum, and I've just written a message there. If you could just say hi, that way I know who's on, and thank you to Makan, Sarah and Jamin for doing that already. I'll tick them on the roll. Just need to know who's online so that I can record it. It's just for these double lessons. And Sarah. So we've got 4 viewers online at the moment. If you could just go to the Sector Forum and say hi in the message in the chat that I've just created. That'd be good. We'll start the lesson soon. The other thing I'll do is during the actual lesson itself is I will disable the forum as well, so you can't actually write any messages to each other while the lesson's going, while I'm explaining the content. And then again, once I have finished explaining the content, then we can answer some questions that people have. So we've got 10 viewers at the moment, but so far on the Sector Forum, there's only 3 of you that have actually said hi. So if we can get all you guys that are online on YouTube just to jump over onto Sector Forum as well and to say hi before we start. If the Sector Forum's not there, just refresh the page. Refresh your Sector Forum page. I've got a direct message from Jamin about the test. I will explain the test as well, a bit more about the test for next week during the session today. Thanks, Jared. So if you guys can go on the forum, the one that I set up is the chat right at the bottom. So it says, talks about today's lesson, and says we are streaming online on YouTube. Say hi, please say hi in Sector, and it's the one in the bottom. We've got Hannah on there, good. We've got a whole lot more people on there. Yeah, sorry Enrico. So I've turned off live chat on YouTube for the main part of the lesson. I'll turn it on again once I've delivered the content, and then we can ask some questions then. But for the meantime, all I'm doing is the roll. So Jared's here. Going through, Allison's here. We got Enrico. Keeps wanting to become mod. It's not happening, Enrico. Isaac's here. Tyler's here. Marius is here. Jared's here again. Talon is here. Katiana. Sorry guys, this is just going to be a little bit weird to start these lessons, but that's just the way it is. Isabella's here. Yep. Carla is here. Where's Carla? There she is. I'm here. Lisa Marie is here. Anno is here. Let's keep them going, guys. It's great to see you all online. So we've got about half the class that have said hi on chat. We've got 21 viewers on the YouTube. And just remember on the forum, if you could just say hi in the thing. I'll refresh my page one more time, even though it's lagging so much. I'm going to have to close my browser in a second. And we'll start the lesson very, very soon. I might just show you guys what I see on my screen right now so that you can see how much it's lagging. I don't think it's got anything to do with the YouTube stream. I think it's just got to do with how all the other teachers are trying to do their online streaming here and so forth. So hi everyone, welcome. So we've got a couple more people if they've just joined us. So we've got Anushka, Josh. I'm just going to click on this one. So when you're doing the roll, try and look for the most recent post that I sent to you so that you guys know. So we've got Anushka was here, Josh Rimmer was here. And yes, I'm scrolling down and that's how slow it is. I saw Nathan Healy there as well. Jake's here. This is good, guys. Back to down. So we've got 21 viewers online. So where's that one? The other thing I'll say is in the forums, guys, please don't start new chat sections. Just leave that to me. I'll start the chat sections and you just write underneath, okay? So Henko's here as well. Josh, Kuko. Yep. And I think that's about it. So I'm going to turn off the sector forum in 10 seconds and then we'll begin. So all these new messages, I'm just going to delete them. The ones that create your own sections on the sector forum. Please leave that for me to create the sections. Otherwise the forum's going to get cluttered with a whole lot of stuff. Alright, so I'm just going to close the forum. So we're just missing, so this is the last chance for Christina, for Ben. I don't see Rachel, Marcus, Kathy, Chris, Hannah. I thought I did see Hannah. Let's go back up. Pretty sure Hannah was one of the people. This is how slow it is, guys. This is my day so far. Painful. See, it's just like a screen of greyness. Like that's Kathy and Rachel. Cool. Kathy, Rachel, Hannah was there as well. So, Georgia Smith. Where's Georgia? So Jamin. Yeah. Thank you guys for being so patient and having to look at all this scrolling up and down. Okay, I think that's it. All right, so the time is 11:30. So I guess any messages on the sector that happen before 11:30, I'll say, yep, you're present. But for now, I'm going to close the forum. And I'm going to close my Year 8 forum for now, so I don't get any random messages throughout the chat. And I'm also going to close my web browser so that we get optimum streaming going on. And then we'll jump over to Year 9s. And let's begin. It took us 10 minutes to do the roll. Not ideal. All right, so I'm just going to go over to here. Well, that's a bit crazy. So today we're going to look at this idea, irrational numbers and surds. It's exercise 2I. Might just do a quick recap of the other day before we start. So 2H was what we did the other day. And this was the one where we looked at binomial denominators and simplifying things that have surds on the bottom of our fractions, and having a little expression on the bottom. So this one had 2 square root 5 minus 2, and this one was 3 square root 2 plus 2 square root 3. And so these more difficult binomial expressions, you require it to multiply by the conjugate of the denominator. So 2 square root 5 minus 2 is the starting thing, and we multiplied by 2 square root 5 plus the 2. So that sign there we replace with the opposite sign. And it's no use just timesing it by one case of these. We have to times it by the 2 square root 5 plus 2 over the 2 square root 5 plus 2. And that's because we are essentially multiplying our initial fraction by 1 because we've got the same things on the top and the bottom. And then once we've done that, that's the starting point. Then becomes the case of multiplying out the brackets. And this one, I've only got 2 lines going through this because 2 main ones that we get to do. So it's the first 2 terms that we multiply together. That gets us 20. And then it's the last 2 terms we multiply together, which is -4. And the reason why you don't do the other terms with this method is because we've got a minus and we've got a plus, they will cancel each other out, and that's the whole point of doing it, because we don't want square roots on the bottom when we're rationalizing the denominator. And yeah, so that's the process there. And we did a couple of examples, and this one all we did was we factorized out of 4 out the front, and we simplified it down to that stage. And I gave you a whole bunch of questions to do. I really hope you had a go at them. Remember, you've got your maths-based task as well. Your maths-based task will have a few of these questions in there to do as well, which is due Monday next week. Every Monday is a maths-based task. And just before we get on to 2i, the stuff for 2 that we're doing today, the thing I wanted to mention is in regards to the test for next week. So some of you know this already, but others of you don't. The test is going to happen on the Thursday of next week, as was originally planned on Sector. And the way it's going to happen is we're going to direct message you, everyone, the test, most likely Thursday morning sometime. And what we want you to do is during the double lesson that you have maths, so right now during the periods 4 and 5, is we want you to download the test. We want you to, if you can, it might make it easy if you can print it and work on paper, that would be ideal. But if you can't, that's okay as well. We would like you to work through the test, so either print it and work through it on paper, or if you can't print for whatever reason, just work through the test in your exercise book. So just open up your exercise book and label each question. So say question 1 of the standard section, do this, and question 2 of standard, do this, and you just show you working out and reference the questions. And of course, if you're doing it that way, it might take you a little bit longer, but that's okay. Try your best to stay within the time limit if you can, but I understand for whatever reasons that might be difficult for some people. And then once you're finished, you need to be able to scan your work. So get your phone or your parents' phone, take some snapshots of your work, bundle your images together, either as a PDF. If you can download an app that can do that, that would be ideal. But if you can't, if it's just a bunch of images, like scanned pages, scanned photos, bundle them together if you can, and direct message them back to me. And if you can do that before the end of school on Thursday, then what we will do is I will mark them. We'll set a particular time that you have to get it in by, but I'll let you know very clearly what that is, and then I'll mark them, and then I'll record the mark on Sector as a comment. So it won't actually go towards your final grade. It'll just be a comment saying what you got for each of the sections and a percentage, and then you can get that as feedback to see how you're going in maths. And but if you decide not to do the test, we'll have to let Mrs. Robertson know and the heads of students know. So it'll be Mr. Elliott for you guys to say that you're not completing the work that we've assigned to you. So a test is pretty important still, even though it's not going to go towards your final grade. We still want you to do it. We still, like, I will mark everything that gets handed in to me. But if you choose not to, for whatever reason, we'll have to refer you on to Mrs. Robertson and Mr. Elliott, and they'll probably get in touch with your parents and say, look, there was a test and your son or daughter didn't choose to do the test, and then, yeah, we'll see what happens from there. Okay, it's enough of me blurting about the test, but if you've got any questions about the test, later on in the session, I will open up the chat and we can have a chat about it. But in the meantime, let's get into this stuff. So we are going to be dealing with decimals today, really. So the first question says, what is the difference between terminating and recurring decimals, and give some examples. Give an example of each. So a terminating decimal, it might actually be better if I type. I don't know, let's try it out compared to if I write. So terminating decimal, this might be better actually than writing, if I can spell, decimal, still laggy, stops. That's what terminate means. So terminating means stops, okay? For example, you might have a decimal that is, oh my goodness, that's how long it took for me to select a pen. There we go. You might have an example of a fraction that goes like 1 divided by 4, and you work that out, and it's a terminating decimal because it goes 0.25 and there's nothing else at the end of it. There's no other numbers afterwards. It stops. It's a terminating decimal, okay? A recurring decimal, see if I can type it in the same spot, kind of. Oh man, this is not good. Oh, I'm just going to see if this is going to allow me to do this. Excellent. Okay. A recurring decimal continues forever. That's what recurring means. And sometimes there's a very obvious pattern to it, other times there's not. But a recurring decimal does continue forever. And the example I've got here is 1/7. I'll see if I can draw again. I'll see what happens. 1/7, yeah. It's not too laggy at the moment. It's dealable. So when you go 1/7 on your calculator, you get this 0.142857. And then you might notice a couple more digits on your calculator, but it actually goes like this. And it keeps going, following this pattern, 0.142857, 142857, and I won't draw another one, but it's basically that pattern over and over again. So what we tend to do is we do a line on the top to say that decimal goes forever and ever following this pattern. It goes from 1 to 7, and then it repeats itself. It keeps doing that pattern over and over and over again. So I'm just going to symbolize that. We're going ... at the end. So that's what recurring decimals are. They go on forever. And what we're going to work out today is how to convert recurring decimals into simplified fractions, and do some stuff with rational and irrational numbers in a minute as well. All right, so let's do this one. And I might just draw from now on. Let's just draw rather than type. Okay, so the first example we've got here, I'm just going to extend my page, give myself a bit more room. There we go. All right, so we've got 27 viewers. Let's go. All right, example. And it might help just to give you guys something to do as well. If you follow along, if you want to write down what I'm writing in your notes book or something like that, that way you can keep focused and pay attention and not get distracted, and you've got something to do while I'm talking as well. So 0.12121212 ... This is the first one. We're going to write that thing as a simplified fraction. Okay, so I'm going to show you a couple of ways you can do these ones. One slightly longer than the other. I'll show you the long way first, but the long way is good because it works for really hard examples as well. Okay, and then I'll show you the easier way for like simple patterns like this one. Okay, so for this one, I'm going to use a bit of algebra. I'm going to say let S equal my starting number, 0.121212 forever and ever and ever. Okay, so what I'm going to do to help me with this problem, I'm going to essentially start with this statement, which is basically, here's my starting number, S for starting number, and I'm going to do something to both sides of my equation so that I can get part of my repeating decimal on the left-hand side of the decimal point. I'll get my mouse so you guys can see. I'm going to get part of my decimal on the right-hand side. If I multiply it by a number, it's going to go over to the left-hand side. And the number I'm actually going to choose for this one is 100. I'm going to multiply both sides of my equation by 100. So S, if you multiply S by 100, it becomes 100S. If I multiply this number on the right-hand side, it is a recurring decimal. It goes on and on forever. But if I multiply it by 100, I will get 12 point, and I'll see if I can get it so that it lines up underneath each other. Perfect. Dot, dot. So I've got the left-hand side is S, that's my starting number, equals 0.121212. And then I'm multiplying both sides of my equation by 100, and that's still true. Like, I'm not changing algebraic rules or anything here. I'm going to multiply both sides by 100. But now, this is the tricky bit. What I'm going to do is I'm going to represent this whole line using the information that I've got already in here. I'm going to split this 12.12121212 that goes on forever into two parts. Okay, so I'm going to say that the left-hand side is 100s. That's going to say the same. I'm going to say 100s over here. But the right-hand side, I'm going to split this 12.121212 into, well, it's the same as this 12. I'll get the highlighter out. It's the same as 12. And then, if I change the color of the highlighter, if it'll let me without it taking forever and lagging so much. I'll try this one more time. If this doesn't work, then I'm going to give up. Okay, yeah, we're good. And this bit is the same as this bit. So I'm going to write the right-hand side as being, it's equal to 12. And it's also equal to 12 plus 0.121212 forever, right? So that's what the right-hand side is. I've got 12 plus 0.121212. So I'm going to rewrite all this as, another line of working out, change pens to black, 100s equals 12 plus, and with this thing, we had this at the very beginning. This was our starting number. This was our S that we had right at the very beginning. This S over here, S is equal to all of that. So I'm going to replace this in our equation with the letter S, like this. And now I have an equation, and this equation is the one we're going to solve, and we're going to solve for S. We're going to work out what S is, and the equation's going to help us rewrite this recurring decimal, but as a fraction, as you'll see. So if I'm solving an equation, S is the value that we're trying to work out. So I'm going to collect like terms. So I've got 100s here, and I'm going to subtract the S from the right-hand side. So it's 100s minus S. Doing it all the steps to show you. And I've got 12 left over. Be very patient with that. Okay, so 100s minus S is 99s equals 12. If I was to solve that equation, but not get it as a decimal, but just as a fraction, S is going to equal 12 over 99. If we divide both sides by 99, S is going to equal 12 over 99. And that's what this number is as a simplified fraction. 0.12121212, because it's got the two numbers that are repeating over and over again. It's out of 99. And the two numbers that are repeating over and over again is the 1 and the 2. 12 out of 99. So with this understanding, what you can actually do is any number that has got a two-digit repeating cycle, you can say, well, if you follow the same rule, it's going to be whatever the two numbers is over 99. So for example, so another example over here, let's do it like a dotted line, split this up, 2. So if you had a number like 0.7878, nope, try that again. That wasn't me, that was lag. 787878, dot, dot, dot. Okay. So using the same idea, you could say let S equals 0.787878, blah, 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 and do the 100s thing and split it up exactly like we just did before. But because this is a two-digit repeating pattern, it's going to follow the same rules. It's going to be out of 99, and we can say that this number here is going to be 78 over 99. And sometimes when you do that, you can simplify the fraction a bit further. You can think of the numbers that go top and the bottom, and some fractions can be simplified. But this one, I'm pretty sure can be, yes. So this one can go to 26 over 33. Because 3 will go into the top number, and 3 goes into that bottom number as well. So you can think of this as a 2-digit number that's repeating over and over again is going to be that number there over 99. And then you can simplify this fraction to get to this thing. You might say, Mr. Wager, what if it's not a 2-digit repeating number? What if it's just a 1-digit repeating number? Or what if it's something even harder? What do we do? So let's just do the 1-digit one first. So we need a lot of space for this next thing. Thank you. Thanks again for being patient with all of the slowness and the lag, and might feel that I'm going really, really slow, or it might feel that I'm going really, really fast in terms of the understanding, but we'll see how we go. Okay, so let's say example number 3. This is a nice easy one. Let's say, what if we've got 0. Let's go 1, 1, 1, 1, 1, 1 forever. It's just a one number that's repeating itself. One number that goes on forever. So if it's just a 1-digit one, then you say that this is the same as 1 over 9. So whatever the number is that repeats itself over 9. If it's a 2-digit repeating number, like the one we had, these top ones, then it's the 2 digits that are repeating over 99. Okay? And so if it's 1 digit, it's just whatever the repeating number is over the 9. If it's a 3-digit repeating number, let's put in something like 0.127, 127, 127. Just going to pause for a moment and see if you guys can have a think about what you reckon that would be as a simplified fraction. I'll just get my calculator out, see if it can be simplified. Nope. Okay, so this is going to be, because it's a 3-digit number, it's going to be 127 on the top. And on the bottom, because it's a 3-digit repeating number, it's over 999. That's how that is. Okay, so if it's a 2-digit number, it's over 99. If it's a 1-digit number that's repeating, it's over 9. If it's a 3-digit repeating number, it's over 999, and the pattern continues. Okay, so they're the nice ones, I guess. But that's going to go out the window completely, because I'm going to show you an example which is quite a lot harder, and in which case we're going to have to resort back to this crazy method again of doing the algebra approach to tackle it. Okay, so let's go to, it's going to put a little asterisk next to this one. So think of this one as like a maybe advanced or extension idea. Okay, so I'm going to go challenge. Will you accept this challenge? All right, so the one we're going to do is this. We're going to write this decimal as a simplified fraction. So 0.51, and then the bit that's repeating is 262626 forever. So the 26 is the one that's repeating, but the 51 at the start kind of messes everything up. Okay, so how we would write this would be, we'd say 0.5126, and the 26 we'll put a line on the top to say that's the bit that's going to repeat forever and ever, but the 51 stays what it is. So the reason why this one's different to the ones before is because we've got this extra 51 that just appears at the beginning but nowhere else in the pattern. So we can't do this thing over 9 and 999 and 99 anymore. It won't work. Okay, so that's why we're going to go the algebra method again. All right, so we'll go through this slowly and see how we go. So the first thing I'm going to do is going to say, let S equal our starting number. So our starting number is 0.5126. And I might just make the 2 6s a different color. Keep it red. I'm going to keep them red the whole time since the lag is not too bad at the moment. It's workable. Okay. So if S is equal to 0.5126262626, what I'm going to do is I'm going to do the same trick as I did before. I'm going to multiply this number by a number so that the 5 and the 1 get over to the left-hand side of the decimal point, and the 26, the bit that's left over here, I'm going to keep that where it is. Okay, so I'm going to multiply both sides by 100 for that one to go out. So times it by 100, I'm going to get 100s equals, that is a terrible S, try my best to round that around. Okay, so I've got 100s, actually I'm going to redo that one completely because it looks more like a 5. 100s equals, and then if I times the left-hand side by 100, I've also got to multiply the right-hand side by 100. So I'm going to times this thing by 100, so it's going to be 51, and I might just move it so I can get it kind of lining up. Might just move these out the way too. Come on. So 51 point, and when I times the right hand side by 100, we're basically just shifting it. I'll get rid of these things because it gets confusing otherwise. Okay, Okay. So my goal is I want to get the bit that's recurring just to the right of the decimal point. So the bit that's repeating, the repeating pattern just to the right over here. Okay, so that's the first bit. The next thing is I'm going to do another multiplication. So I'm going to think of my initial number here, and my goal this time is to get the 26 over on the right hand side of this thing. Just to show you what I mean of that, if I times s by 10,000, so 10,000. So if I times the, or think of timesing s by 10,000, or think of timesing this one by 100. So I'm just going to get another equation where I'm going to shift it across so that the 2 and the 6 are also on the left-hand side of the decimal point. So it'll all come together in a minute. It's just the setting up part of it. So I'm timesing by another 10, or timesing s by 10,000. Okay, so it's going to be 10,000 s on the left-hand side equals, and then if I times this by 10, it's going to be 5,126. And I'm going to see if I can, it's going to be hard squeeze, but we'll try our best. And then the bit that's repeating, yes, I know I've gone with the color option. I didn't go with that 26 in there. That's red. I'm going to wait 26 in there. There we go. All right. So we are halfway through this. So what we're going to do now is we're going to do a subtraction. We're going to do a subtraction so that we kind of get the number that we had to start with linked together. So we're trying to do something in a way so that it kind of gets rid of the decimal point thing. So what we're going to do is we're going to get the 10,000s, and we're going to take away the 100s. So we're going to start with the 10,000s on the left-hand side. We're going to do a difference here and see what we end up getting. And we're going to take away 100s. So I'm going to do this take away a bit weird. I'm going to do it like this, minus 100s. And I'm going to go equals. And on the right-hand side, I'm going to do the same two numbers. I'm going to say that this thing here, take away this thing here, and see what we end up getting. There's a point to this. So we've got 5,126.262626 ... and then I'm going to take away 51.262626, and I'm just going to highlight a couple of things. Actually, I'll put a ... here as well. Okay, have a look at what we've got. Oh, I don't know if this is going to work. Very laggy. Okay. Thank you for your patience. It's just very slow. Okay. All right. Here we go. So let's have a look at what we've got. Let's start with the left-hand side. So we've got 10,000s and we're taking away 100s. So we can do the maths there. That's just going to be 9,900s. 9,900s. On the right-hand side, I've got this number, and what I've highlighted is the 0.26666 that goes on forever, dot, 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 and the 0.26666 dot, dot, dot goes on forever. For these two numbers here, the way that I've manipulated it, the way that I've multiplied these two special numbers by the numbers that I chose, is because when I do this subtraction, these two yellow sections are going to cancel each other out. So on the right hand side, it's not going to be a decimal thing anymore. It's just going to be 5,126 take away 51. So these two things here are going to cancel each other out because they're recurring decimals. They're going to go on forever. And so I've got 5,126, this number, take away 51. And then it ends up being 5,075. 5,075. Notice we don't have any more decimal places, and now we've got an equation. We've got this s, which is still on the left-hand side. We're going to solve this equation to work out what s has to equal. So s is going to equal, I'll do it underneath, just give me more space. Okay, so s is going to equal the number on the other side. Whoops, that's what happens when you lag. Yes, concentrating very hard, choosing the right color. Okay, so what I might do is I'll try this, force it, override. Okay, OneNote is saying it's having a bit of a moment here where it's not letting me select the black marker. So what I'm going to quickly do is I'm going to close out of OneNote. Oops, not starting soon. I'm going to go to be right back. No, not that one either. Apologies, everybody. Okay, I'm going to click on this one, and I'm just going to close out of my OneNote and reload it again. Let's give it one more try, see if it's done it. Okay, maybe... I'll try it one more time. Okay, cool. I think we're back on track. Live screen. Let's go. There we are. All right, cool. All right, so we're trying to solve this equation for s, and so s is going to equal the 5,075 over 9,900, like that. And 25 happens to be a number that can go into both the top and the bottom numbers, and so that can actually be simplified. It goes to 203 on the top and 396 on the bottom. That's simplified. So that's our starting decimal was 0.5126262626 forever and ever, and it simplifies to 203 over 396. And the way we did it is we started off with a bit of algebra. We multiply both sides by 100 to get the 51, the part of the number that's not repeating on the left-hand side. And then we also did another times by number. So we times this 100s by another 100, and we got 10,000s, and we times this thing by 100, and it got to 5,126.26 recurring. And the reason for that is so that we can get both of these numbers here, having the 0.26 number repeated afterwards, so that we could take them away from each other, and then that enabled us to get a fraction that we could then simplify. So the trick is to try and get two numbers with repeated decimals that you can take away from each other based on the original number that we had, and then subtract them. Okay, so what we might do is I'll keep going with the stuff in here. I won't talk about continued fractions with you guys because I think that's just going to be stuff for the extension class. But I'll just talk about this last little section here. And let's do this bit. So explain what rational and irrational numbers are and give an example of each. So a rational number, let's see if I can type still, a rational number yep, it's coming up, can be written as a fraction. So we can write, a number is called rational if we can write it as a fraction. So any number that you can do something like a number over another number, like p over q, and p and q must be integers. So integers are whole number values. So where p and q are integers. Integers are whole number values. They can be positive or negative. Oh man, it's so laggy. Stop. I just wanted to write a closed bracket. Try that again. There we go. So every single rational number can be written as a fraction like this, and all integers are rational as well, because you can always just divide by 1. So for example, number -3, that's rational because you can say -3 is the same as that. So that's a fraction, and the fraction has a whole number on the top and a whole number on the bottom. So this number here we say is a rational number. So any number that can be written as a fraction is called rational. Okay. Whereas the flip side to that is, the opposite of that is irrational. So for example, write in red, irrational numbers cannot be written as a fraction of integers. So the other thing is with irrational numbers, it can't be written as a terminating or repeating decimal either. So what is an example of an irrational number? If it can't be written as a fraction, and it can't be written as a terminating or repeating decimal either. So let's have a look at this. E.g., let's look at the square root of 2. Square root of 2, if you were to put this on your calculator and work it out, it's 1.4142135562. So 1.4142135562. This one goes on forever, but it's not a recurring decimal because there's no pattern. There's nothing in the digits here at any stage where they repeat themselves into a bit of a pattern. So we can't actually write this as a fraction like we did the earlier ones. So those recurring decimals that we did earlier always had a pattern involved with them. Another example of an irrational number is pi. Pi comes along a lot when we're dealing with circles, and this one has no pattern either. 3.14159 divided 2. And then, yeah, that goes on forever as well. And people have had competitions where they try and say how many decimals of pi that they can remember and things like that. But yeah, you can't write pi as a fraction. Some people have got some approximations to pi, like 22/7 is an approximation to pi, but you can't write it using integers and get exactly what pi is. Pi is special. Pi is irrational. Okay, so that's the difference between rational and irrational. So rational is any number you can write as a fraction with whole numbers or integers, and irrational is where you can't do that. You can't write it as a fraction. Okay, so I'm going to leave the last bit of the notes about continued fractions off altogether completely. So that's one less thing to worry about for you guys. And the work that I want you to do, because I'm going to open up for questions now. The work that I want you to do is exercise 2I, and it's got a bunch of these ones you have to practice with the recurring decimals to fractions idea. So I'll write the work in here so you can do it. So exercise 2I, it's on page 68 to 69. of your textbooks. And we're going to go questions. Let's go 1A, C, E. Let's go question 2. Let's do the same thing, A, C, E, G, and I. And then question 3, we'll go with just ACE again. See the pattern. And then question 4, you get to say which ones are irrational. So question 4, we want all because it's just yes or no. Question 5, yeah, do that one. It's just question 5 is just putting numbers in order. And then question 6, let's go with A, C, E, G, I, K. And that'll do for now, I reckon. So that is the work that I want you to do. I'll leave that on the screen for a while, and you can always access this in your OneNote notes as well, because I'm going to sync the page, so it should just sync with you as well. So now I'm going to figure out how to open up the chat again and answer any of your questions that you have. So just bear with me. Might do this one actually while this is loading. I'll be right back. I'm not going anywhere, just enabling the chat in YouTube. And I'm going to answer any of your questions that you have. This is so slow. This is my screen, you can see. It's black. Oh, we got some action. Okay, it's going to go in here. I'll be right back. So I'm just going to enable the chat in YouTube. So give me a moment. And only chat if you would like to ask a question to do with the work that we have. I prefer if you didn't use the chat as a way of just, you know, talking with each other and saying, hi, how you going, hi. There's other things you can do for that. Allow live chat to replay. Alright, so see if that works. Alright, so here we go. Chat should be up and running. Just going to close out of this again because it's so slow. Live Leader says, what is in the test, sir? Okay, so the test has got everything that we've done this term. So all the topics we've covered this term. So let's just say what they are, what chapters they are. So we've done chapters 2, we've done chapter 8, and we've done chapter 1. So 1, 2, and 8. So chapter 1 was on algebra, chapter 2 was on Pythagoras and surds, chapter 8 was on index rules and indices, negative indices, and all that kind of stuff. I'll go back to live screen so you can see what the work is to do. So these are the questions for you to work on. You can just have this running in the background. I'll have the live chat running for, thanks Tyler, just for a little while longer. And then I'll have the forum up and running for the last, say, 20 minutes or so. You guys can ask me questions in there. Yes, the test is going to be marked, but it's just going to be written as a comment in sector, so it's not going to be going towards your final grade. Preparing for fractions are in math space, and I learnt it myself. I got 90%. Are you proud? Yes, I am proud, Enrico. Good job. Oh, Georgia's here. Cool. I can mark you off, Georgia, as being present. When you simplify the number with the 0.5125, why is it separate? Ooh, let me see. Trying to go back to, can you think about which example that was, Makan? No, Enrico, can't help with that, sorry. 0.5125, I'm trying to look through. Oh, that's 51261. Oh, that's the one you're mentioning. Okay, cool. Why is it separate? It's because that's just what the harder questions are like. And you do have a few of these practice ones in the exercise, but yeah, they are a bit trickier. But yeah, you have to separate it because we've got two parts of our recurring decimal. We've got the bit that's not repeating and the bit that is repeating. Yep, thanks, Georgia. I got that. The only ones I haven't got marked off the roll are Chris. I haven't got Ruan. I haven't got Christina, and I haven't got Ben, and I haven't got Marcus. We may have to use Teams if it's going to be really laggy like it is, but I've chosen YouTube because the videos that I record, we can save on YouTube as well. It makes it really easy. Christina, yay! Hi, Christina's here. So just missing Ben, Marcus, and Chris, and Ruan. What's Gabe doing here? See you, Gabe. Oh, I figured out with the widgets, Enrico, the widgets don't work at school on the school internet, but they work brilliantly at home. So once and if teachers are allowed to work from home, then we'll get those widgets working fine. I didn't even realize I was at 100 subs, but my thing on here doesn't even update. All right, guys, I'm gonna end this stream. So if you wanted to keep chatting, just write your comments in the sector forum. But as I said, try and keep the stuff in the forum to questions about the work that we covered today. But yeah, I look forward to seeing you guys next time, and have a great weekend. And remember to do your math space task, which is due Monday, and we've got tests next week. Yeah, so the questions that you have to do, Sarah, there, exercise 2i. But you go onto OneNote and you guys can see the questions. You just go to, I've updated my page, so just go to exercise 2i in the content library and you guys can see the questions.